Hi, I'm Cécile Chazot, Professor of Material Science and Engineering, and welcome to the Sustainable Polymer Innovation Lab, or SPIN Lab, where we make new synthetic polymers and new biopolymers for sustainability applications. So this is where a little journey in the SPIN Lab starts, and usually the way I explain how the lab works is I try to explain it in terms of the process we do in the lab. So I'm going to introduce you to the different aisles and areas we have in the lab, starting by here, which is the manufacturing and synthesis aisle. So here in this part of the lab, what we look at is polymer synthesis. A lot of what we do here is synthesis from scratch, so taking small molecule and assembling them so that they form long polymer chains and ultimately fibers, or taking polymers from nature and modifying them to give them additional functions that they don't necessarily have by themselves. So after we made the new polymers or modified biopolymers in the synthesis aisle, we're trying to make it at a scale that simulate industrial scale. And this is what the manufacturing part of the lab is for. And this is where we built pilot scale manufacturing lines to start processing the material in a way that would be industrially relevant for textile and plastic applications. Once we've made new materials, we've processed them into fibers in different films. Now it's time to actually characterize them and actually understand what are the properties of those films, both from an optical perspective, but also just from a physical perspective. When you pull on it, is it elastic? Is it brittle? Or how does it actually look under a microscope? And this is what happened in this part of the lab, which is mostly on materials physical characterization. Once we've made samples and we've characterized what type of materials they are, we want to characterize their appearance and specifically their color. That happens in this room, which is called the optics room. What we do is we look at samples we made that have different colors and look how shiny the colors are, which color we see, and also how angular dependent, so iridescent or non-angle dependent the color is. And all those things are super important when you're trying to think about making samples that have colors for textiles, for instance, because maybe you're gonna want your jacket to be shiny, maybe you're not gonna want that. One of the big problems in the textile industry is textile dyeing. It's currently responsible for about 20% of water pollution worldwide. And so what we're trying to look at is, can we actually make colors without the use of dyes? Can we actually make colors with natural materials like cellulose, which is extracted from plant wools, without having to do a post-treatment to give the fibers or the materials their color? And that happens through a phenomenon that's called structural color, which is the molecules will arrange at the molecular and nanoscale in such a way that they interact with visible light and reflect ambient light in a way that you're going to see only some colors. Thank you so much for coming on a tour to the SPIN Lab, and I hope to see you next time.